Okay, we're in lesson 6.1, part 2. We're going to start out with a few definitions, as almost always. First of all, perimeters. So with similarity and congruence, we have some special things about perimeters. The ratio of lengths in similar polygons is the same as the scale factor. Okay, the ratio in lengths. And remember, the perimeter is the length around a figure. So the ratio of lengths in similar polygons is the same as the scale factor. Theorem 6.1 shows this is true for the perimeters of the polygons. Here's the theorem. So we have perimeters of similar polygons. If two polygons are similar, then the ratio of the perimeters is equal to the ratio of their corresponding side lengths. Remember, perimeter is I add the distance all the way around. Add the distance all the way around. So if we show that, we know this is similar to this, which is stated right there. We can say that KL plus LM plus MN plus NK, which is KL plus LM plus MN plus NK, over PQ plus QR plus RS plus SP. PQ, QR, RS, SP. Add that together and that together, which is the perimeter of, let's call it figure 1. The perimeter of figure 1 over the perimeter of figure 2. That's equal to the ratio of the side over the side, side over side, side over side, side over side. Okay? So it's a theorem that states sort of the obvious, but because the theorem has been written, we can use it to make our work a lot easier, which I will show you with an example. Okay? A town is building a new swimming pool. An Olympic pool is rectangular with length 50 meters and width 25 meters. The new pool will be similar in shape, but only 40 meters long. Okay? Find the scale factor of the new pool to an Olympic pool. So we have an Olympic pool is 50 by 25. Okay, let me underline that. Olympic pool is 50 by 25. The new pool, similar in shape, but only 40 meters long. Okay? So we want to find the scale factor of the new pool to the Olympic pool. So I'm going to do new, if I can spell. I'm going to do new over Olympic. That's an N. Over Olympic. Okay, so the length of the new pool is 40. The length of the Olympic pool is 50, which is 4 over 5. We found the scale factor. Pretty simple. Okay, I'm going to go to the next page and finish the problem. Okay, remember the Olympic pool is 50 by 25, my bad. This is length by width, and the new pool is 40 by, we'll say W, okay, length by width. Find the perimeter of an Olympic pool and the new pool. So we're going to use that theorem 6.1. Okay, the perimeter of the Olympic pool is 50 plus 25 plus 50 plus 25, right? It's 150 meters because we went all the way around the rectangle. Okay, 50 plus 25, 50 plus 25. You can use the perimeters of similar polygons theorem to find the perimeter of the new pool. So we have new pool over Olympic equals the scale factor. New pool over Olympic. Cross multiply, 5x equals 4 times 150 is 600. Divide by 5, divide by 5, x equals 120. This is the perimeter of the new pool. Okay, we just use that perimeter of similar polygons theorem to write your proportion. Okay, let's try one on your own. In the diagram, A, B, C, D, E is similar to F, G, H, J, K. Find the scale factor of F, G, H, J, K to A, B, C, D, E. So make sure the F, G, H, J, K is on top, okay? Then go ahead and find the value of X, and then find the perimeter of A, B, C, D, E, okay? I'm going to push pause. You go ahead and work on it. Okay, let me walk you through this. First of all, find the scale factor of F, G, H, J, K to A, B, C, D, E. I put 15 over 10. Okay, then I found the value of X. I have 15 over 10, which is here. 15 over 10 is equal to 18 over X. Notice I went in the same order. 15 over 10, 18 over X. Cross product, and I got X equals 12. Then I found the perimeter of A, B, C, D, E, and I had to move it up here because I needed more space. The perimeter of F, G, H, J, K, I added everything together. Okay, 15 plus 9 plus 12 plus 15 plus 18 and got 69. Then I set up a proportion. Okay, the perimeter of F, G, H, J, K over the perimeter of A, B, C, D, E is equal to the ratio we found, the scale factor, 3 over 2. Cross product, I got the perimeter of A, B, C, D, E is 46. Okay, last slide of definitions. Similarity and congruence. Notice that any two congruent figures are also similar. If they're congruent, they are similar. Okay, their scale factor is 1 to 1. There's something missing here, triangle ABCD and triangle DEF, rewind. In triangle ABC and triangle DEF, the scale factor is 5 over 5, which is 1. Okay? So if you just compare DEF to ABC, you get 5 over 5, which is 1. So congruent figures are also similar, and their scale factor is 1 to 1. Okay, so you can write ABC is similar to DEF, and ABC is congruent to DEF. Okay, let's move on. Corresponding length. You know that perimeters of similar polygons are also in the same ratio as corresponding side lengths. You can extend this concept to other segments in polygons. Okay? And then our key concept, corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygon. Okay, we sort of already learned that, but this talks about we don't just have like the size of the polygon. Okay, we're also talking about altitudes, medians, what else? Mid-segments. It deals with all the pieces. Okay, altitudes, medians, mid-segments, etc. So those are the corresponding lengths, not just the sides of the polygon, but what the other things that we've learned about triangles at least. And here we have an example where we have an altitude. Okay, if you remember, from the vertex to perpendicular is an altitude. It's also here a median because it goes from the vertex and it cuts it in half. And it's also a perpendicular bisector because it's perpendicular and it bisects. Those are those definitions that we had fun with in Chapter 5. So, in the diagram, we know that TPR is similar to XPZ. Find the length of the altitude PS. Okay, first let's figure out the scale factor of TPR to XPZ. Okay, the scale factor of TPR to XPZ. I'm just going to do XTR over XZ. I get 12 over 16, which simplifies to 3/4. Little hiccup in the recording there, sorry. Okay, so that's our ratio. Because the ratio of the lengths of the altitudes are similar in triangles, because of the ratio of the lengths of the altitudes in similar triangles is equal to the scale factor, you can write a proportion for the altitude. So if we're trying to find PS, okay, I can put that over 20. Because PS, this is an altitude, the altitude of triangle TPR, the altitude of triangle XPZ. I can set that equal to the ratio we just found. And cross product 4 times PS equals 60. PS equals 15. It's the length of the altitude. Okay, you try. Okay, in the diagram, triangle JKL is similar to triangle EFG. Find the length of the median, which is the median KM. All right, so find your ratio first, and then use that ratio find the scale factor first, then use the scale factor to find the length of KM. I'm pushing pause. Okay, I set up my scale factor, my proportion to find my scale factor. I did JM over GH, 48 over 40, simplified to 6/5. Okay, then I set up a ratio here, 6 over 5 equals KM over 35. Because I did JM over GH, I want KM over 35. Cross product, 210 equals 5 times KM. Divide both sides by 5, and you get KM equals 42. Daily homework quiz. Write it down. There's 2 more. It's worth 2 points. Write it down. I think there's something missing here. This should be a triangle. That should be a triangle. Last one. Go ahead and write them down. Good job, guys.